Good day everyone. In this video I want to discuss one projectile motion problem. Alright, so you look at the question. The question says that a ball is kicked horizontally at 8 meters per second from a cliff 80 meters high. So how far from the base of the cliff will the stone strike the ground? Okay, so because we're dealing with two-dimensional problems, it would always be useful to split them up into x and y directions so that the x direction has their own set of equations and the y direction has its own set of equations. Okay, so we can do this clearly by using a table, right? And from this table we have four equations, and then we can make some assumptions with regards to the problem at hand. So the first one being, we can say that okay, in the x direction there is no acceleration, so ax is 0, and in the y direction, because we have gravity, we will say that ay is equals to negative g. Okay, now, as you can see, the ball is kicked horizontally, right? So there's no initial velocity in the y direction. So what that means is that uy is going to be 0. Okay? So because ax is 0, we can get rid of this. We can get rid of this. And then ay is negative g, so we'll just substitute it in. And then uy is 0 as well. So uy is 0. Okay? So our equations are simplified tremendously. Okay, tremendously. So if we establish our equations to be in the, here's the y direction and here's the x direction, and we draw a cliff and the ball is kicked that direction, it will fall down. So we are looking for Sx, which is the range or how far it is from the base of the cliff, right, after some time. And that time is determined by this 80-meter drop. So once the ball has fallen down by 80 meters, when you click the time, you stop the time, that is when you can measure out the range. So how do we do this? Well, we know that Sy is going to be 80, and based on our table, it's going to be negative 1 over 2 gt squared. Now, because we have established that going up is positive y, then we will have to put a negative sign for the 80, so that we have negative 80 equals to negative 1 over 2 gt squared. Okay, so we can then multiply both sides by a negative sign, by negative 1, and we'll get positive on both sides, and then multiply or bring over the 2 to this side, which we will get 160 equals to gt squared. Now we know that g is equals to 9.81, and that gives us a value of approximately, so let's put 160 over 9.81 equals to t squared, right? And then we can rearrange that, to be square root of 160 over 9.81. Okay, so that is going to be approximately 4 seconds. Once we have the time, so this is the time that the ball hits the ground. Okay, it's when the ball hits the ground, and since we want to find the range, which is Sx, we can immediately substitute the values in. So the t is from the y, this one, and then the ux is given in the question, 8 meters per second. So let's count that out. So 8 meters per second multiplied with 4 seconds, and that would give you a value of 32 meters approximately. Okay, so because it's happening simultaneously, the moment that the ball travels 80 meters down, right, 80 meters in the y direction, and it hits the ground, at that time, at that momentarily, for that moment, right, it also covered a range of 32 meters. So if I were to draw it back, right? If I were to draw it back, here's my cliff, here's my ball, right? I'm going to throw it down, right? It travels down by 80 meters, and it travels in that direction by 32 meters. It travels by that direction, I mean the positive x direction. All right, so we have found the range, right, from the base of the cliff. So from the base of the cliff to the moment of landing, it is going to be 32 meters. All right, so that is all for this problem video. I'll see you in the next video. Thank you.